sklearnpreprocessingBinarizer. Description: the binarizer class in scikit-learn sklearn is a data preprocessing technique used to transform numerical features into binary values 0 or 1 based on a user-defined threshold. This is particularly useful for binary classification problems where a feature is considered present or absent based on its value relative to the threshold. Inputs: X, a NumPy array or pandas data frame containing the numerical features that need to be binarized. Threshold, a float value defining the threshold for binarization. If a feature value is greater than or equal to the threshold, it is converted to 1, otherwise, it is converted to 0. By default, the threshold is 0.0. Outputs: transformed X, a NumPy array or pandas data frame containing the binarized features. Self, the binarizer object itself, allowing for reuse of the same transformation on different datasets. Steps: data initialization: the binarizer object is initialized with the desired threshold value. Feature transformation: the binarizer transform method is applied to the input data X. Each feature value is compared to the threshold, and a binary value 0 or 1 is assigned based on the comparison. Metrics: accuracy evaluates the performance of a classification model on the binarized data. Precision and recall measure the model's ability to correctly identify positive and negative instances. Visualization plots: scatter plots visualizing the distribution of the binarized features to understand the impact of the transformation. Histograms illustrating the frequency of 0 and 1 values after binarization. Fine-tune parameters: threshold, adjust the threshold to control the binarization point. A higher threshold results in fewer features being classified as 1. Uncertainty methods: confidence intervals estimating the uncertainty associated with the threshold selection. Cross-validation evaluating the performance of the binarizer with different thresholds using cross-validation. Challenges and fixes: challenge 1, choosing an appropriate threshold. Sample use case that resulted in challenge 1: a dataset with a highly skewed distribution of values might require careful selection of the threshold to avoid binarizing. Most values is either 0 or 1. Fixes to challenge 1. Domain expertise: consult domain experts to understand the significance of different threshold values in the context of the problem. Exploratory data analysis: visualize the distribution of the features and identify potential thresholds based on meaningful breakpoints. Grid search: experiment with a range of threshold values using grid search cross-validation to find the optimal threshold that maximizes model performance. Challenge 2: handling missing values. Sample use case that resulted in challenge 2: missing values in the input data might lead to errors during binarization. Fixes to challenge 2: imputation: fill in missing values using strategies like mean, median, or mode imputation before applying the binarizer. Removal: exclude features with a high percentage of missing values if imputation is not feasible. Separate handling: develop separate logic for handling missing values within the binarizers. Implementation: